Good morning, students. Chapter 2, Units and Measurement continue. Yes, in last lecture we have discussed about dimensional formula. Dimensional formula and dimensions. Okay, yes, we can represent each and every physical quantity as combination of several fundamental quantities. Okay, and yes, we have discussed about some quantities, some physical quantities, and how to obtain their dimensional formula. Now today we will see some more physical quantities. Okay, here it is. Here it is. Yes, plane angle. We know that plane angle, yes, what is its definition? Plane angle is equal to, it is arc upon radius. We know its equation, okay? Plane angle is equal to arc upon radius. So what is dimensional formula of plane angle? That is theta. That is theta. Okay? Plane angle is arc. Arc means it is nothing but distance. Then, so its dimensional formula is L1. Radius, it is also distance. Its dimensional formula is L1. So L1, L1 constant, it remains only 1, or yes, you can write it is M0, L0, T0, because any quantity raised to 0 is equal to 1. Any quantity raised to 0 is equal to 1. Okay, and yes, whenever dimensional formula is M0, L0, T0, that quantity is called dimensionless. That quantity is called dimensionless. Okay, so yes, you have to remember this. Okay, whenever dimensional formula, if dimensional formula is 1 or M0, L0, T0, okay, each and every quantity, then it is called dimensionless. Okay, next is solid angle. Next is solid angle. What is definition of solid angle? Solid angle is equal to area upon radius square. Radius square. So again, what is dimensional formula of solid angle? What is dimensional formula of solid angle? Okay, dimensional formula of solid angle is equal to area. What is dimensional formula of area? It is L square. What is dimensional formula of radius? Radius means, yes, it is distance length, so it is again L square. So L square upon L square cut, it will only 1. What we can write, it is M0, L0, and here it is T0. So again, this solid angle is also dimensionless. Is also dimensionless. Clear about this? So yes, we have two dimensionless quantities. First plane angle and then solid angle. Okay. Now next one is, yes, next one is angular displacement. Angular displacement. Angular displacement is nothing but angle. Yes, angular displacement is nothing but angle. And what is dimensional formula of angle? It is M0, L0 and T0. Okay, yes, angular displacement means nothing but angle, that is theta 0. It is theta 0, and its dimensional formula is M0, L0 and T0. Clear about this? So yes, this point you have to remember. Okay, what is dimensional formula of angular displacement? Next one is, yes, next one is angular displacement. Angular displacement. Angular displacement is equal to, what is its equation? Its equation is angular velocity. Angular velocity is equal to, it is angular displacement. It is angular displacement upon time. Angular displacement upon time. Remember, yes, we will discuss this equation in chapter number 7, that is system of particles and rotational motion. Okay, so yes, angular velocity is equal to angular displacement upon time. Angular velocity is equal to angular displacement upon time. Angular velocity is denoted by omega. Okay, so its dimensional formula is equal to dimensional formula of angular displacement. Here it is, angular displacement. Its dimensional formula m0, L0, T0. Time, its dimensional formula is T1. So if I am taking this T1 in numerator, it will become m0, L0, T minus 1. Clear about this? So yes, it is dimensional formula of angular velocity. It is dimensional formula of angular velocity. Now, next one is dimensional formula of angular acceleration. Angular acceleration. Okay, and yes, angular acceleration is equal to it is angular velocity divided by time. Divided by, okay, angular displacement is equal to it is angle. Angular velocity is equal to it is angular displacement upon time. Acceleration is equal to it is velocity upon time. Angular acceleration is denoted by alpha. So its dimensional formula is equal to dimensional formula of angular velocity. Where is angular velocity? Here it is. It is m0, L0, t minus 1 divided by time. Means here it is t1. Simple. So if I am taking this t1 in numerator, it will become negative. Yes or no? And its power will be, it is m0, L0, and here it is t minus 2. And here it will be t minus 2. Clear about this? So yes, it is dimensional formula of angular acceleration. Then next quantity is moment of inertia. Next quantity is moment of inertia. And moment of inertia is equal to, it is mass into radius square. Radius, or we can say distance square. Okay. So yes, moment of inertia is indicated by capital I. So its dimensional formula is, what is dimensional formula of mass? Yes, it is m. Dimensional formula of radius means length. It is L and it's square. So yes, here it is ml square. Here it is ml square. Clear about this? Yes, you can also write this as m1 L2 T0. Okay? Yes, you can write this. Okay, so yes, it is about moment of inertia. Next one is, yes, next one is periodic time. Next one is periodic time. Yes, periodic time means it is time to complete one revolution. It is time to complete one rotation. It is time to complete one oscillation. So yes, periodic time means nothing but it is time. So its dimensional formula, periodic time is denoted by capital T. Its dimensional formula is equal to dimensions of time. And yes, here it is T1. Or we can say it is M0, L0, T1. Okay. Next one is frequency. Next one is frequency. Okay. And yes, frequency means what? Numbers of oscillations in 1 second. Numbers of oscillations in 1 second. So frequency, its equation, yes, we know its equation. Frequency means it is 1 upon periodic time. Means it is 1 upon periodic time. So dimensional formula of frequency is denoted by F. Its dimensional formula is equal to 1 upon dimensional formula of periodic time. What is periodic time? Here it is. Its dimensional formula is T1. So is equal to, it is T minus 1. Or I can write it is M0, L0, T minus 1. So see, here it is, angular velocity, its dimensional formula, m0, L0, t minus 1. Frequency, its dimensional formula, it is m0, L0, it is t minus 1. Clear about this? So yes, remember about this, dimensional formula of these two quantities are same. Dimensional formula for these two quantities are same. Clear about this? So yes, these are some quantities, dimensional formula you have to remember. Okay, next quantity is surface tension. Next quantity is surface tension. And yes, surface tension means it is force per unit length. Force per unit length. Then how to obtain dimensional formula of surface tension? Surface tension is denoted by, yes, it is T. Then is equal to dimensional formula of force. Do you remember dimensional formula of force? Yes. What is dimensional formula of force? It is MLT minus 2. Where dimensional formula of length is, it is L. So this L cut. Then it is only MT minus 2. Or you can write it is M1 L0 T minus 2. It is dimensional formula of surface tension. It is dimensional formula of surface tension. Clear about this? So yes, if you know equations, yes, how to remember this all dimensional formula? If you remember equations, you can easily derive dimensional formula. Okay, now next one is, see, here it is. Yes, electric current. Electric current, we know dimensional formula of electric current because electric current is base quantity, fundamental quantity, and its dimensional formula we know that is indicated by E. So dimensional formula of current I is equal to, it is A, only A. Or yes, you can write this as, it is M0, L0, T0, A1. Clear about this? How to write these quantities? Okay. Now next one is electric charge. Electric charge, yes, if you know equation, I is equal to Q upon T. So Q is equal to, it is electric current into time. Yes, electric charge is equal to electric current into time. Electric charge is denoted by Q, so its dimensional formula is equal to dimensional formula of electric current. What is dimensional formula of electric current? It is A. Dimensional formula of time, it is T. So yes, it is AT, or you can write M0, L0, T1, T1. Simple. So yes, it is dimensional formula of electric charge. Okay. Next one is, yes, potential difference, or I can say only potential. Yes, these all quantities, okay, about electric current, about electric charge, potential difference, resistance, capacitance, inductance, we will see in 12. Right now you have to remember equations. Okay, so see here, potential difference or potential. Yes, what is definition or what is potential? Potential is equal to work per unit charge. Potential is defined as work per unit charge. So what is dimensional formula of potential? Yes, dimensional formula of potential. Potential is indicated by V. So its dimensional formula is equal to dimensional formula of work. Okay, now again, what is dimensional formula of work? Yes, dimensional formula of work is, it is M1 L2 T minus 2. While what is dimensional formula of charge? Here it is AT. Or we can say A1 T1. Okay, so see how to simplify. M1 only one term as it is. L2 only one term as it is. T two terms, T minus 2 and T1. So if I am taking this T1 in numerator, it will become negative. So minus 2 minus 1, or directly it is minus 2 minus 1. So it will become minus 3. So it is T minus 3. If I take this A1 in numerator, it will become negative. So it is A minus 1. So it will become A minus 1. Clear about this? So yes, it is dimensional formula of potential. Okay. Now for resistance. Yes, you know Ohm's law. Ohm's law, that is V is equal to IR. Ohm's law, that is V is equal to IR. V is equal to IR. Then how to obtain dimensional formula of resistance? What is resistance? Resistance is equal to, it is potential difference divided by current. It is potential difference divided by current. So dimensional formula of resistance R is equal to, chalo, what is dimensional formula of potential difference? It is M1 L2 T minus 3 A minus 1. What is dimensional formula of current? Obviously it is A1, or you can write only A. So yes, here how to simplify? M1 L2 T minus 3 A minus 1, and in denominator it is A1. So if you take this A1 in numerator, it will become minus 1, A minus 1, A minus 1, it will become A minus 2. It will become A minus. Clear about this? So yes, it is dimensional formula of resistance. It is dimensional formula of resistance. Okay. Potential, it is work per unit charge. Dimensional formula of work and dimensional formula of charge. Okay. Resistance, yes, you know equation of resistance. That is V is equal to IR. V is equal to IR. Then R is equal to V upon I. Okay. Yes. Next one is capacitance. Next one is capacitance. Capacitance C is equal to, it is Q upon V, means charge upon potential. Means charge upon potential. Capacitance C is equal to, it is charge upon potential difference. And capacitance is denoted by C. Its dimensional formula. What is dimensional formula of charge? It is A1 T1. What is dimensional formula of potential difference? Here it is. It is M1 L2 T minus 3 A minus 1. Now you have to simplify this. See, M1, only one term. And if I take M1 in numerator, it will become M minus 1. L2, it is in denominator. If I take L2 in numerator, it will become L minus 1. Now about T, here it is T1, and in denominator it is T minus 3. So if I take this T minus 3 in numerator, it will become positive. Yes or no? And this 1 and 3 to be added. So yes, it is T4. Here it is T4. Here it is A. Here it is A minus 1. If I am taking A minus 1 in numerator, it will become positive. Then A1 into A1, it will become A. It will become A. Clear about this? So yes, in physics, we have to deal with numbers of physical quantities, and there are numbers of dimensional formula that you have to remember. But how to remember? You have to remember only dimensional formula of fundamental quantity and then equations. That is, electric current is equal to charge upon time, potential difference is equal to work upon charge, resistance is equal to, it is potential difference upon current. Yes, you have to remember such equations only. Okay, and then you can easily derive. Dimensional formulas. Clear about this? Okay, now we will see some questions based on how to find dimensional formula and units. Now we will see some questions. See, for example, if you are given a gravitational force acting between two masses M1 and M2 separated by distance r. Okay, gravitational force acting between two masses M1 and M2 separated by distance r is given by F is equal to G M1 M2 upon r square. Yes, you know gravitational law. Okay, F is equal to G M1 M2 upon r square, where G is gravitational constant, universal gravitational constant. Then yes, your question is find unit and dimensional formula, find unit and dimensional formula of G. Find unit and dimensional formula of G. Yes, in this question you are given equation and you are given each and every quantity. Okay, what each and every quantity indicates. What each and every quantity indicates. Okay, again, gravitational force acting between two masses m1 and m2 separated by distance r is given by F is equal to G m1 m2 upon r square, where G is gravitational constant. Find unit and dimensional formula of G. How to find? First of all, you have to make G as subject. Here it is. F is equal to G m1 m2 upon r square. Then first thing you have to understand or you have to see, that is how to make G as subject. Yes, you are given equation. F is equal to G m1 m2 upon r square. Okay, as you have to make G as subject. G as it is here because it is in numerator. Here this side is F. First of all, take this two term m1 and m2. If we take this two term m1 and m2 in opposite side, here it is in numerator, here it will be in denominator. R square it is in denominator, here it will be in numerator. Clear about this? So yes, G is equal to this fr square upon m1 m2. G is equal to this fr square upon m1 m2. Okay, I will write it again. That is G is equal to it is f r square upon m1 m2. Now first of all we will see how to write unit. Yes, how to write unit. Okay, yes, unit of G. Unit of G is equal to force. Capital F is force. Yes, gravitational force acting on two masses m1 and m2 separated by distance r is given by F. So F is gravitational force. What is SI unit of force? It is Newton. R is separated by distance r. R is distance and distance its SI unit is meter. But that as here it is r square, so here it is r square. Divided by, sorry, it is meter square. It is meter square because what is SI unit of distance? It is meter. M1, M2 mass. So yes, M1 its unit is kg. There it is also kg. So I can write this as it is Newton meter square upon kg square, or I can write this as Newton meter square kg raised to minus kg raised to minus. Clear about this? So yes, it is how to obtain unit. How to obtain unit. Now how to find dimensional formula? Again I will write the same quantity, but like this. Okay, how to find dimensional formula. How to find dimensional formula? Yes, we have equation that is G is equal to fr square upon m1 m2. So dimensional formula of G is equal to dimensional formula of F, dimensional formula of R its square divided by dimensional formula of m1, dimensional formula of m2. Yes, you have to first of all make this G as subject. So G is equal to it is fr square upon m1 m2. How to find unit? And now how to find dimensional formula? Yes, you know dimensional formula of force, that is m1 l1 t minus 2. Yes or no? Yes it is. Dimensional formula of r means distance, it is l2 divided by m1 means it is mass. Yes, so its dimensional formula is m1. m2 it is also mass, so its dimensional formula is m2. Clear about this? So is equal to, here it is, this m1 third, then there is only first one term having m, and if I take this term in numerator, it will become minus 1, m minus 1, l1 and l2, so it will become l3. Okay, and yes, here it is t minus 2. So it is dimensional formula of gravitational constant. It is dimensional formula of gravitational constant. Clear about this? So yes, this method, okay, how to find unit and how to find dimensional formula, that you have to remember. Yes, that you have to remember. Okay, now next one. See, now next one. Okay, if heat passing from conductor is given by equation. Is given by equation. What is equation? See, dq upon dt is equal to this k a dt upon dx. dq upon dt is equal to this ka dt upon dx. This one equation that you will see. Okay, where what is dq? dq is heat energy. dq is heat energy. Where dt is time. Where a is cross sectional area. This dt is change in temperature. It is change in temperature, and dx is distance, and dx is distance. And what about k? K is coefficient of thermal conductivity. Coefficient of thermal conductivity. Yes, you are given one equation. dq upon dt is equal to ka dt upon dx. dq heat energy, dt time, a cross sectional area, dt that is changing temperature, dx is distance, and k is coefficient of thermal conductivity. Now what is your question? Yes, your question is you have to find dimensional formula of coefficient of thermal conductivity. Okay, coefficient of thermal conductivity. Yes, you have to obtain dimensional formula of K. So first of all, you have to make this K as subject. See, again I will write equation. It is dq upon dt is equal to Ka dt upon dx. Ka dt upon dx. So first of all, we have to make K as subject. How to make K as subject? Okay. Yes. This side dq upon dt as it is. This a and dt, they will be in denominator, a and dt, and this dx we have to write in numerator is equal to it is k, is equal to it is k. Simple. Okay. How to make k as subject? How to make k as subject? As a and dt, they are in numerator with k. On opposite side it will be in denominator. dx in denominator, it will be in numerator. How to make k as subject? Okay. Now how to find dimensional formula of k? So dimensional formula of k is equal to dimensional formula of dq, dimensional formula of dx divided by dimensional formula of dt, dimensional formula of a, dimensional formula of dt. Okay. Now one by one we have to put dimensional formulas for each and every quantity. dq, what is dq? See here. dq is heat energy, any type of energy, its dimensional formula is same. N is equal to dimensional formula of what? That is m1 L2 T minus. What is dimensional formula of heat energy? Yes, it is m L2 T minus 2. dx, what is dx? It is distance. So its dimensional formula is just L1 divided by dt. Yes, what about dt? Yes, dt is time. So its dimensional formula is T1. A is cross-sectional area, any area, cross-sectional area, contact area, surface area. Its dimensional formula is same and it is L. Next one is dt. Yes, this dt means it is temperature. This dt means it is temperature. And what is dimensional formula of temperature? Yes, dimensional formula of temperature is K. The dimensional formula of temperature we have to represent as K1. Okay. Yes. Now we have to simplify. M1, M only one term, so it is directly M1. L, L2, L1, L2. So I can cut this L2 and L2. So there is only one term, that is L1. Now T. Yes, here it is T minus 2. Here it is T minus 2. Okay. And yes, here it is T1. Here it is T1. So T minus 2, T1. It will be T minus 3. It will be T minus 3. Simple. And about K, there is only one term, so I can write it is K minus 1. I can write it is K minus 1. Again, you are given this equation. You have to first of all make this K as subject. Then K is equal to it is dq dx upon dt a. dq energy, m L2 t minus 2, dx distance means it is L1, dt that is time, a that is area L2, and dt that is temperature, that is K. So yes, m only one term, that is m1, L2, L1 and L2. So yes, this L2 L2 cut, so that is only L1. T minus 2, here it is T1, so it is minus 2 minus 1, it will be minus 3, and here it is K1 only in denominator, so you can write in numerator, so that is K minus 1, so that is K minus 1. So it is how to obtain dimensional formula if you are given equation. Okay, now I will give you one question, okay, and yes, you have to obtain dimensional formula of that quantity. See, viscous force F is equal to eta A dV upon dx. F is equal to eta A dV upon dx, where what is F? It is force, eta coefficient of viscosity, A is contact area, dV is velocity, and dx is distance, Okay, each and every term again. F force, you know dimensional formula of force. Eta coefficient of viscosity, that you have to find. A contact area, again area means each and every area, that is cross sectional area, okay, contact area, surface area, the dimensional formula same. dV velocity, dx distance. What is your question? Yes, you have to find dimensional formula of coefficient of viscosity, and yes, compulsory you have to write its answer in comment box. You have to write dimensional formula of viscosity in comment box. Clear about this? So yes, it is one of the important topic, dimensional formula, dimensional analysis, how to obtain dimensional formulas, that now you know. Okay, yes, you have to remember only equations, and equations we will see in chapters. Okay, already you know some equations, chapter number 3, 4 and 5 and 6. So yes, you have to remember equations, you can easily derive dimensional formula. Clear about this? So yes, write this answer in comment box, and for today this is it.